Let's see, we got to go halfway down to get to the math. Hope that's not the flu.
I just have a cold, I think. I don't know.
Oh. Did we do number 10? Does that look familiar to you? Okay. So let's.
Yeah, we stopped at number 10.
That's what I thought. That's what my note said. Let's look at number 11, and I can, here, let me blow that up a little bit. Yeah, in fact, let me blow it up a lot, because that'll give me more room to write. Okay, so what you want in front of you is paper and pencil and a calculator. Now, what kind of calculator? They do have some restrictions. What do you have for a calculator?
A TI-83.
That's fine. That's allowed on the test. So that's a good one to have for practice. All right. So what are we going to do here? Go ahead and read through this.
Equation above B and D present the price per pound in dollars of beef and chicken. Price per pound of beef. Okay. B and C represent price per pound in dollars of beef and chicken.
Remember, the goal on all of these word problems is to put it into an equation. If you can put it into an equation, then you can solve it.
Okay.
So start from the end. What's the question is, what was the price per pound of beef when it was equal to the price per pound of chicken? Well, what would that suggest we do to those two equations?
Put them together?
Make them equal.
Yeah.
Remember what B is. That's beef. C is chicken. So the question says is, what was the price per pound when it was equal to the price per pound of chicken? So I'm going to set this equation on the top equal, in other words, B equal to C. Okay, so that gives me a linear equation. Only has one variable in it, x, and that means we're going to be able to solve for x.
Okay.
Okay, so there's our equation. Can you see that okay?
Yeah.
And solving for x is exactly, well, it's not quite what they want. We'll be able to solve for x, and then we'll have to substitute it in to one of these equations to figure out what that price is. Notice that all of our answers are prices. They're not in the number of weeks. So the goal here is not just to solve for x. The goal is to solve for x and then solve for either C or B. And I say either because it's when they're equal. So if I solve for C, I'm solving for B also.
Okay.
So let's look at this equation down here. How do I solve this?
You add the the common ones. I mean, like one with x to x, and then.
Am I going to put the x's on the right side or the left side of the equation?
The right. No, the left.
No, I like the right. Why? Why is the right better than the left? It's going to leave the coefficient positive. Notice that if I move this 0.25x to the right, it turns into 0.15x, which is positive, and I want that. Okay? So
Okay.
I'm going to end up with 0.15x over there, which means I have to move that number to the left by subtracting it from both sides, and that leaves me with 0.6. Now, notice no negative numbers, no negative coefficients. What's the next step?
Dividing that.
Do it in your calculator.
0.25.
No, you're dividing 0.6 by 0.15, right?
4.
That's what I'm doing.
4.
So 4 is the answer. Unfortunately, that tells us they become equal 4 weeks after July 1st. So now tell me what that price is going to be. What's the easiest one to plug it into?
Into 2.35 plus
Yeah,
0.25.
why? Because 4 times 0.25 is 1.
Yeah.
So what's the answer?
3.35.
Yeah. It actually looked like that would be the easier one to plug it into just because the numbers tend to be smaller. But when I do 0.4 times 4, I get 1.6. So I still get 3.35. But it is a little bit of an oddity here where that becomes the easier one to plug it into.
Okay.
I would say that's a medium problem. And mainly because there's 2 steps. If they would have asked you to solve for x, I would have said it's an easy problem. But asking you to solve for the actual price means you had to solve for x first and then plug it into either equation to solve for the actual price.
Yeah. Okay.
Okay, number 12.
Line on the x side, the line passes to the portion. It has a slope of 1/7. Y is on the line. A slope of 1/7. Which of the following points lies on the line?
When they ask you a question like which points lie on a line, what you need is the equation of that line. Because what we're looking at are x points and y points. So if you give me the equation of that line, then I can tell you which of these points are on the line. They have to fit the equation. So let's start there. What's the general form of the equation of a line?
Y equals mx plus b.
What's the b stand for?
I know x is slope.
No, m is the slope.
Oh yeah, I'm a slope.
B is the y-intercept. This thing is called slope-intercept format. There's actually 3 different formats. This one's called slope-intercept because you have a slope and you have an intercept. Okay? So in our problem here, the intercept is usually where you want to start. Read the first sentence.
A line in the xy plane passes through the origin.
Stop. What's the y-intercept?
XY. Wait, a line in the...
If I have a straight line that passes through the origin, where is it crossing the y-axis?
0.
Okay. So now we have y equal mx. What's the slope?
1/7.
So now we have y equal 1/7 x, and that's the equation of the line. And that, incidentally, is the same as this. A lot of people, boy, if you give them this, they cannot go back to that. So be able to. Okay? All right. So now we have the equation of the line. Once we have the equation of the line, which of the following points lies on that line? Well, does that point lie on the line? And by that I mean when you plug in 0 for x, is y equal to 7?
No.
Does B lie on the line?
Yes.
When you plug in 1 for x, what is y equal to?
1.
Well, y would be 1/7 times 1.
Oh.
What's that?
Oh, 7.
1/7.
Yeah.
Anything multiplied by 1 is that thing. In other words, multiplying by 1 never changes anything. So it's 1/7. It's not 7. That's not right either. Keep going. Plug in x. 7 for x. What do you get?
7/14. If you put in
Just
7.
plugging in for x. Where are you getting 14?
I don't know.
Well, first of all, we're doing C. So plug in 7 for x, and what is y equal to?
7/49.
No, you're plugging it into too many places. If I plug in 7 for x, I get 1/7 times 7. That's what I'm doing. It's plugging in 7 for x. Now you're multiplying 7 times 1/7. What's that equal to?
1.
Okay. You do not want to have to look at your calculator to figure that out. You should know that that is 1. Okay? So it's not 7. So C doesn't work either. And now finally, we know D has to be the right answer because the first 3 were not. So we're actually done with the problem. We've solved it. But just so you know, plug in 14 for x. What do you get?
2.
That's the right answer. When x is 14, y is 2. So therefore, that point and that point alone of those 4 points lies on that line. So this is a medium problem because there were 2 things I had to do. I had to figure out the equation of the line, so I had to know the general format. I had to know it goes through the origin, so that makes B 0, has a slope of 1/7, that makes M 1/7. So there's our equation, and then we just have to plug in all the points, and there's no other way to do that. You just have to start plugging in points. But you got to be able to do the math. In other words, when you plug in 0, what is y? Still 0.
Okay.
All right. 13.
To the following.
Now, these can be kind of intimidating. Most people have enough problems with fractions, and this is a fraction in a fraction. So, you cannot do this until that is a single fraction. Okay? In other words, right now, the denominator is the sum of two fractions. We can't do anything with this. Actually, I was just looking, yeah, okay, now looking at their directions. I had never seen this before, but I don't see how that's important. So ignore that for the moment. So we have to figure out how to add these things. Let's go over here and figure out how to add them. How do you add fractions? What's the first thing you have to do when you add fractions?
Can't you do 1 plus 1?
Nope, that's multiply.
Wait, no.
If I was multiplying these two fractions, that's what I would do. But when you're adding or subtracting fractions, there's always one thing you have to do. Always. What is it?
Oh, I can't remember.
Find a least common denominator.
Oh.
So,
Okay.
let's go backwards. Tell me how to add those fractions without your calculator. Your calculator won't do you any good here, because you're not going to be able to add these two fractions with your calculator. You could add these two with your calculator, but you got to know how to add fractions. How do I find the least common denominator?
Isn't that 12?
Okay. So the way I'm going to do it is like this. I'm going to make that a 12, and I'm going to make that a 12. Now, tell me what the numerator of the upper left one is.
4.
And the upper right?
3.
So what's the answer? 4 twelfths plus 3 twelfths?
7 twelfths.
All right. So you know how to add fractions. Okay? So these are just two fractions. The only difference is there's a variable in these. So what'd you do to find the common denominator?
Couldn't it be 6?
No, you multiplied them. You multiplied 3. When we did 1/3 plus 1/4, you knew the common denominator was 12 because the product of those two numbers is always a common denominator. Might not be the least common denominator, but it's always going to be a common denominator. You'll still be able to work the problem, even if it's not the least common denominator. Well, when you have variables involved, like this problem, you just have to multiply the two things together. Okay? So, my least common denominator, and I don't need to actually multiply these together yet. That's what it's going to be. Let's just leave it unmultiplied until we see that we need to multiply it. In other words, don't do any more work than you need to. Now, the key question here is what goes there?
Would it still be 1?
Nope. That changes the fraction, does it not? The goal is to not change this fraction. Whatever we put in that numerator, this fraction has to remain the same as what we started with. So what can I put in that numerator so that I still have 1 over x plus 2? About x plus 3.
Wait, why?
Well, look at it for a minute. The reason I leave the denominator unmultiplied is so that I can ensure by looking at that I haven't changed it. You say, why? Because my x plus 3 cancels with this x plus 3, and I'm left with 1 over x plus 2. So when I do it this way, I can check it immediately to make sure I have not made a mistake. Okay. Now, what's an easier way of doing that? Is to take that denominator, divide it into your common denominator. What do you get? X plus 3. Multiply that by 1. That's what goes in that numerator. But the real key of these problems is to make sure that when you're done, you have not changed the fraction. You're not allowed to change fractions. That's an absolute rule of math. You're allowed to manipulate them. You're allowed to multiply top and bottom by the same number, but you can't change the value of it. And in this case, the bottom fraction is exactly the same as the top fraction. So, what goes here?
X plus 3.
Well, would that give you that right there?
Oh, wait, X plus 2.
There you go. Now, what's the next step? When you add fractions with both with the common denominator, you're allowed to do what?
Cancel each other, cancel them out.
No, you operate on the numerator. In other words, the answer still has the common denominator in it. That doesn't change. Not like when you multiply. Changes when you multiply, but when you add something that has common denominators, the common denominator stays the same. So now I'm going to add those two numerators. Well, what do you get when you add those two numerators?
X plus 5?
No?
Wait, are you multiplying it?
Oh, you're adding them, right? Adding, right there. What's x plus x? If I have one apple and I have another apple, how many apples do I have?
2.
2x. X is my apple. Now add the two numbers together. How many numbers do I have?
5.
All right. So,
That'd be 2x.
remember that that is just the bottom. Okay? So, let me rewrite this. In other words, remember I started with the bottom only. Okay? So, what I really have now is 1 over that. That's the problem right there. That's what that problem says. Oops. We've just manipulated. We've added the two fractions on the denominator, so now we have this denominator. Now, how do you divide by fractions? If I said divide 1/4 by 2/3, how would you do that?
Oh my gosh, we just did this.
You flip and multiply.
Yeah, you flip the 2/3.
You flip the bottom and multiply. In other words, there is no such thing as a division problem. Everything can be turned into a multiplication problem. So 1/4 divided by 2/3 is the same as 1/4 times 3/2. And once it's a multiplication problem, it's easy. What's that?
3/8.
Yeah, multiplication is easy. Addition is what's hard. In other words, when you get multiplication, you can multiply numerators and multiply denominators. You don't need to find any common denominators or anything. And since division can be always turned into multiplication, that's easy. So multiplication and division are much easier than addition and subtraction. Okay. So now, how am I going to rewrite this? Well, how do I divide by fraction?
You do x plus 2, x plus 3, and then put the 2x plus 5 on the bottom.
Okay, now we still don't yet have to multiply those two together. Haven't needed to yet. Now let's look at our answers. Is it A?
No.
Is it B?
Yes.
Possibly, certainly possibly, right? In other words, we're looking at x squared plus 5x plus 6 everywhere through this problem. You know that these two things have to multiply to x squared plus 5x plus 6. It just has to be true. So you never do have to multiply them. you can immediately know, well, we got to have a 2x plus 5 in the denominator. That's actually the only answer that has a 2x plus 5 in the denominator.
Mm-hmm.
All right. This definitely borders on the medium and maybe the hard. Again, every one of these problems has like 4 different math principles. I think they do that on purpose. I'm not sure that the test does it quite so much like that. In other words, this could be a training guide, not so much an example of what the test questions are going to be like. I hate to say that, but it seems like every single problem has giant math principles, multiple ones in every problem. All right. Well, this information over here doesn't do us too much good at the moment. What is true about that? What's true about 8 and 2? When you're looking at exponential expressions, which these are because the variables are in the exponent, makes it an exponential expression. So I know how to divide. If I said I have b to the 7th divided by b to the 4th, what's that?
B to the
Third.
23rd.
When you're dividing, same base, you subtract the exponents. Okay? But if I tell you that you have 3 to the 7th divided by 2 to the 5th, there's no rule that applies to that. You can't simplify that. In other words, you got to either have the same base or the same exponent. Either one allows you to simplify it. But you got to have one or the other. Okay?
Okay.
Now, if we look at this problem, that means we need to figure out how to make that the same base. So is there any number that is the common exponential base between 8 and 2?
4?
No, 2.
Oh. Oh, yeah, okay.
The reason is I have to be able to write 8 as a power of 2. There it is, right there. There's my 8. Now I can do that. Divide it all by this. Now, what's the numerator equal to?
2 to the 9, no.
All right. We need to back up here. There's 3 rules you absolutely have to know to take this test successfully. And here's what they are. B to the x times b to the y equals what? B to the x plus 1. In other words, I am multiplying the bases, so I'm adding the exponents. B, let's give an example of that, just so it's clear. If I had 2 to the 3rd times 2 to the 4th, what's that equal to?
4 to the 7th.
Look at the one above it. B to the x times b to the y equals b to the x plus y.
2 to the 7th.
That's rule number 1. Huge one. Rule number 2. B to the x divided by b to the y is equal to what?
B to the xy.
Nope.
Wait.
You never do the same thing to the exponents that's being done to the base. In other words, in the first one, I was multiplying the base. So I'm never multiplying those exponents. I'm adding them. And in the second one, I'm dividing the base. So I'm never dividing the exponents. I am subtracting them. So 3 to the 5th divided by 3 to the 2nd equals
3 to the 3rd.
Okay. It's rule number 2, most important one. Finally, rule number 3. If you have b to the x, and that whole thing is being exponentiated to the y, what's that equal to? This is what I call double exponentiation. In other words, the thing in parentheses is already being exponentiated, and we're going to exponentiate the whole thing. So what's that?
B to the, I don't know.
Well, you multiply the exponents.
Okay.
Notice what we're doing in every one of these. We're doing one less step, math-wise, to the exponents than what's being done to the base. In other words, in number 1, the bases are multiplying, the exponents are adding. Addition is one level less than multiplication. Same in 2. Bases are dividing, the exponents are subtracting. Subtraction is one level less than division. And in number 3, this really should be called single exponentiation, but I realize that students remember it more if you think of that as double exponentiation. But the fact of the matter is that you're going to do one level less to the exponents, which is multiplication. Multiplication is definitely less than exponentiation. You would agree? 3 times 3 is not as big as 3 to the 3rd power. So exponentiation is a level above multiplication. So those are the 3 most important rules when the base is the same. So let's go back over here and look at that. So remember, I wrote 8 as 2 to the 3rd to the x power. This is 2 to the y power. Now, what can I do to the numerator? And which rule am I going to use?
2.
Nope.
What?
Just looking at the numerator. We're just looking at that. That's double exponentiation. You're going to use rule 3.
Oh, okay.
So what is that equal to?
So 2 times 3 times x?
2 to the 3x.
Okay.
In other words, it's correct. You are multiplying those together, but they both stay as exponents. It's just now they stay as a single exponent. Now I'm still dividing by 2 to the y. So now which rule am I going to use to simplify this? Remember, I still have the same base. As long as I got the same base, I can use one of these rules.
Rule 2.
Okay, so what's that answer equal to?
2 to the, wait, rule 2.
Just subtract the exponents. That's what that means.
Oh, 3x minus y?
Yeah, that's simple. It's not, in other words, I know it was confusing because I used the variables x and y up there, but don't think of it like that. Just you're subtracting exponents. Okay, so that's what that thing is. Notice how long it took us to get there. That's why I'm suspicious of these problems being on the test, because they're too long. I mean, it's taking us 10 minutes to just go through them. Hold on one second. Turn the light on. It's getting dark here already. Same where you're at, I imagine. Okay, so now let's go back and look at why they gave us that. Because this doesn't do much good. I don't see any answers that give that, right? What's it say 3x minus y is? The first time I noticed this.
Wait, what? Wait, oh.
What is that? What I have circled there. What is 3x minus y equal to?
12.
So what's this expression equal to?
2 to the 12th.
That's one of the answers. There is another way to do that. If that didn't happen to be so conveniently equal to this exponent, we would have just solved for y, substituted, brought it down, we would have had our answer. Okay? But they made this particularly easy because we did all the heavy lifting by coming up with this 2 to the 3x minus y. And it just so happens that they happen to tell us what 3x minus y was. It's 12. So, look at these rules, memorize them.
Okay.
You will definitely need them. Easy way is just always remember you're not ever doing the same thing to the exponents as you're doing to the base. And that's usually enough that people will figure it out. If you just remember that. You don't have to remember all that. It's one level less mathematically and all of that. Although, to me, I find that helpful to memorize it. So that was probably one of the tougher ones. And 15 is the last problem in this section. So it's probably one of the tougher ones. Now, I've done all these before. This is definitely one of the tougher ones there is. So I'm going to suggest we skip this for now.
Okay.
If we get you're taking this test in April?
Yes.
If we get you to a point where you can do all the easy ones and medium ones, then we'll look at the hard ones. But to be honest, I don't think that's the best expenditure of your time.
Okay.
We got to get you to where you can do all the easy ones and medium ones. You will get a good score if you can do all the easy ones and medium ones, even if you can't do any of the hard ones. You can guess on all 20 hard ones and you're going to get 5 of them right by guessing. So if you get all the easy and medium ones right, plus the 5 hard ones you guess, you'll end up with a really good score. So it is vitally important that you be able to do the easy ones. So I think we're going to kind of proceed accordingly. When we get to an overly difficult one, I'm just going to pass it by. Okay? Now, this is the grid section. No calculators allowed.
Okay.
So, again, 16 is the first one in this section, so it should be easy. These first few should be easy.
3t squared.
If you don't know how to do this, play with some small numbers. By playing with small numbers, I mean try some numbers and substitute them for t and see if you can make that equation work.
Okay.
And I would prefer you be able to solve that equation. You should be able to solve that equation. And if you can't, I'm going to show you how to do it. But you don't have to be able to solve that equation to solve for t. It's pretty simple. Start with a 1 and count up. Does a 1 work?
No.
Does 2 work?
No.
What's 2 squared?
4.
What's 4 minus 4?
0.
So 2 does work.
Okay.
2 is the answer. They don't get any simpler than that. But let's make sure you can solve that equation. T squared minus 4 equals 0. What's my first step?
Putting a number in for t.
No, that would be back solving it. And you could get away with doing that for the SAT test, but you'd never get away with doing that in math class. Let's pretend you're in math class and you have to solve this and you have to show your teacher how you did it.
Oh, add 4.
Okay. Now what?
Divide it.
No, you want the final line to be t equals something. So how do I turn that into just t on the left side? Now you're right, you could divide by t, but then you got t on the right side also, and that's never an answer. When you're solving for a variable, you need the variable on one side and no other of that same variable on the other side. In other words, you want all numbers on the other side if we have an equation that only has one variable. So how do I reduce t squared to t?
Square root it.
Okay. What's the square root of both sides? Well, square root of t squared is t. So that's the major purpose. Square root of 4 is
2.
So that's the algebraic way to solve it.
Okay.
And that's the way you need to know how to do it. But this was such an easy problem that you didn't even need to do that the algebraic way. Just start plugging in small numbers. Always remember, small whole numbers. And usually not counting 0 and 1. You usually want to plug in starting at 2, to be honest. So you would have gotten it the very first time if you'd have plugged in 2 for t. All right, we haven't had a whole lot of geometry problems. So I want to do this one. This is a geometry problem. Now, first of all, this looks tough, does it not?
Yeah.
Second of all, the tougher they look, the easier they are. And I mean that. This is tough. This one, piece of cake. So, first of all, let's go through the information and label up the sketch. Never be afraid to label up your test booklet. You're allowed to do that. Even if they ask you to turn it in, they don't care. It can be all marked up. Okay? So AB, EB, BD, and CD are those following dimensions. So let's just make them that. That's 1800. EB is 1400. BD is 700. And CD is 800. Now, the fact that this problem is even on this test tells you what about these two triangles?
That they equal.
There's two words in geometry. One of them is congruent, meaning equal. The other is similar. Do these triangles look equal?
No.
So they're definitely not equal. One is a lot bigger than the other. Could they be similar?
Mm-hmm.
You know what? They're going to be one or the other. They're not going to have a problem on here where they wouldn't be either congruent or similar. If they're congruent, then they are equal, and this x would be 800. But they're clearly not congruent. But they are similar. What is the similarity ratio? How much each side in this first triangle is what proportion of that second triangle?
Uh, Wait, how big this first triangle is from the second one?
When we talk about scale factor, we're not talking about the total size of the triangle. We're talking about the proportion of sides. If I give you one triangle like this, and I give you another triangle like this, and I say they are similar, and I say that is 4, and that is 2, what is the scale factor between these two triangles over here?
It's 2 times bigger.
2 to 1. That's the answer I'm looking for. 2 to 1. It's actually not 2 times bigger.
Oh, okay.
The area of this bigger triangle is 4 times bigger than the area of the smaller triangle. But when we talk about scale factor, we're not talking about area. That's why I'm reluctant to say the size of the big triangle is twice as big as the small triangle, because it isn't. It's 4 times. But the scale factor is 2 to 1. And the only thing we're interested in doing in this problem is the scale factor. So what does x have to be?
Would you do 800 times 2?
Uh-huh.
So it'd be 1600?
That's it. Now, if they ask you what this distance is, what's that distance?
1400?
No, it's going to be half of this. Remember, when
Oh,
you have similar triangles, the ratio between corresponding sides is the same ratio. If this is a 2 over here, then this has to be a 1. Because they're the corresponding sides. That side there is the corresponding side of those two triangles. And if the two triangles are similar, then that ratio is always the same. And if this was a 3, that would have to be 1.5. In other words, you have to maintain that 2 to 1 ratio when you're talking about every side. So that would be 900. Because this triangle is 1/2 this triangle here. And the corresponding side is AB. Just like 700 was half of 1400. That's kind of where we got our 2 to 1 ratio from in the first place, right? In other words, those are the only two numbers we had to come up with a scale factor.
that makes sense.
So that was an easy problem, as long as you recognize that they are similar triangles. And the thing about similar triangles is their corresponding sides have to be the same ratio. 4 has to be 4 divided by 2 has to be the same as 2 divided by 1, and has to be the same as 3 divided by 1.5. They are all 2 to 1 ratios. And if those two triangles were not similar or congruent, you wouldn't be able to do the problem. So that's what I say, is that when you see a problem like that, you immediately know that you're looking at, in this case, similar triangles. Now, they didn't say they were similar. How do we know they're similar? Because that angle E is the same as that angle D. That makes those two parallel, and that angle equal to that angle. You can go through the geometry, and it makes those two similar. But like I said, if you understand the test, And understand that you would not be able to come up with x unless there was something special going on here. And the only thing it can be is they are similar.
Okay.
But notice that was the last part of the problem. First part was labeling it up. We wouldn't really have been able to do the problem without doing that. All right, 18 is probably a medium problem, but it's systems of equations. They ask a lot of questions about it. So I want to make sure you know how to do it. Okay? When you have a system of equations, they teach you two different ways to handle it. What are they? How can you solve? In other words, if I just have one equation, x plus y equal minus 9, I can't solve that. That's got two variables and there's only one equation. But if you have the same number of equations as you have variables, which we do here, then you can solve. If you have 3 equations and 3 variables, you can solve for all 3 variables. You just have to have the same number of equations as variables. Now, remember the 2 methods they taught you to solve, equate to a system of equations. This is key words right here. You had a full 2 weeks of that in algebra class, and it was called systems of equations. So what 2 methods did they teach you? There's 2 very distinct methods. I'm going to give you one of them. Substitution. What's the other one?
Substitution and oh my god, what's the other one?
Starts with an E,
X.
and an L, and an I.
Elimination.
Those are the 2 methods. There's a bunch of them, but these are the only 2 you really need to know for the ACT or the SAT test. Now, what should we use on this? Which method?
Substitution.
No? Believe it or not, and the reason is that both of these equations are in standard format. And by that I mean the x and the y variable are both on the left and the number is on the right. That's standard format. Okay? In other words, the first equation was not given to us like this. Same equation, but they didn't give it to us like that. If they would have, then we would have x already solved for, and I would use substitution. And I would just go to the second equation. Wherever we see x, we substitute this. But they didn't give it to us that way. They gave it to us in standard format. And when you get both equations in standard format, always use elimination. It's always going to be easier. Now, why? Well, because math says you can add or subtract any 2 equations. Well, I have equation 1 and I have an equation 2, so I can add those 2 equations together or I can subtract them. Now, if I add them, I'm going to have 2x plus 3y equals minus 36, and nothing got eliminated. It's called elimination for a reason. We have to eliminate a variable. So what if I chose to subtract them? Notice what gets eliminated.
The x's.
Okay, now do the rest of it. What's y minus 2y?
Negative 1y.
What's minus 9 minus a minus 25? Do not drop negative signs. When you are subtracting, you have to put every single negative sign you see, otherwise you're going to get it wrong. what is minus 9 minus a minus 25? Even though this is a non-calculator section, I want you to make sure you can do that in your calculator. Just go ahead and do it. Now, this is not automatic to do in your calculator.
Wouldn't it be 16?
Is that what your calculator gave you?
Yes.
Okay. Yes, it is 16.
Okay.
In other words, what we have is minus 9 minus a minus 25. Well, now these two minus signs become a plus. And we really have minus 9 plus 25, which is plus 16. Okay? So what's y? If minus y is 16, what's y?
Wait. Wait, sorry, what?
We have to solve for y. We solved for minus y.
Oh. What'd you, oh, what, you, oh.
Okay, here's the rule about equations. When you want your final line to be y all by itself, then what you have to do is get rid of everything that's with it. Well, there's only one thing with it right now. What is it?
The 16.
No, that's on the other side. That's already gone. The negative sign. So how do I get rid of the negative sign? The negative sign right now is multiplying that y. That's really minus 1 times y.
You divide it?
By minus 1.
Yeah.
And if I'm going to do the left side, I got to do the right side. So what is y equal to now?
Just y.
No, what is that?
Oh, sorry.
Yeah, you're right. The left side is just y. What's the right side?
16.
Negative 16, correct. All right. However, they didn't ask us for y. They asked us for x. So how am I going to get x?
You can put one of them in for y, and then
Okay. Pick an equation to substitute for.
2. The second one.
Why the second one?
Actually, this first one's easier, I think.
A lot easier. In other words, the first one not only has nothing but smaller numbers, but the minus 9 is smaller than that, and the 1y is smaller than 2y. So always choose the easier one. So, okay, so I'm going to do x plus a minus 16, which is the same as, I can drop plus signs. Dropping plus signs don't hurt you most of the time. You just can't drop negative signs. So now solve that for x and we'll have our answer.
9 plus 16. 25.
No.
What?
No.
Oh, that's a negative 9. Okay.
You do that in your calculator?
Yeah, I didn't put the negative 9.
Okay. Here's a secret to those calculators. There's 2 dashes on that calculator, correct?
Mm-hmm.
One of them is subtraction, the other is a negative sign. And when you have a problem like this, which is negative 9 plus 16, that right there, you need to use your negative sign, not the subtraction sign. If you use subtraction, you won't get it right. It'll actually give you the wrong answer. So you have to know when to use that negative sign and when to use the subtraction sign. Although this is a non-calculator part of the test. You're not supposed to be using it anyway. So this is something you need to know how to do. What is minus 9 plus 16?
7.
Okay. You certainly don't want to know how to do a problem and miss it because of you don't know how to do minus 9 plus 16. Agreed?
Mm-hmm.
Okay. That's a good place to stop. 19 is trig. Now, you've probably had a little bit of trig, right?
Yeah, I think so.
Should have had a little bit in geometry and maybe even a little bit more in algebra 2. What do you take?
Yeah.
You're taking algebra 2 right now, aren't you?
Yeah.
Well, they probably haven't gotten to the trig part yet, unfortunately. They might before April. The truth is that you can do just fine on this test without knowing any trig.
Okay.
There's probably like 4 questions on trig out of 60. So you don't need trig. You don't need to worry about it. You can get a really good score without knowing trig. And in all honesty, the trig questions on this tend to be easier type trig. So if you took even 1 week of trig in geometry class, you might have a chance on a couple of them. I don't think it's probably worth our time to teach you trig, maybe, as we get towards the end, and we've taught you how to do all the easy ones and medium ones. But that's our goal, is to try to teach you how to do all those first. Now we're a ways away from that. So, but I'm convinced if you give me the time, we can do it, Haley. I can teach you how to do all the easy ones and most of the medium ones.
Okay.
Okay? All right. I'll make a note. We got through 18, and I will talk to you next time.
Okay.
All right. Bye-bye.
Thank you.